Hi everyone, welcome back to the channel. In today's video, we are diving into a powerful concurrency tool in Java, ReadWriteLock. If you have ever faced performance issues in multi-threaded application where multiple threads just need to read data, this lock might be the solution. Let's start with a simple example. Suppose you have a shared resource. Okay. Now, multiple threads need to read from it, and some need to write to it. If you use a regular synchronized block or a ReentrantLock that we have discussed in last video, then only one thread can access the resource at a time, even if it's just reading. This leads to a big performance bottleneck. Here comes ReadWriteLock, a special type of lock that gives better concurrency. It allows multiple threads to read simultaneously, but only one thread to write, and no other read can happen during writing. Java provides this through the ReadWriteLock interface. So this is the interface. Okay. And a common implementation is Reentrant ReadWriteLock. We'll talk about it. We'll discuss a live coding example I'll walk you through. So there you will be able to see the implementation class, that is Reentrant ReadWriteLock. This ReadWriteLock, it based on a concept of shared read and exclusive write. In concurrent programming, we often talk about shared read and exclusive write. Shared read means multiple threads can read at a time. An exclusive write means when a thread wants to write or update the shared data, it must acquire exclusive access. No other thread can read or write. Means during read, multiple threads can read at a time. Like here, T1, T2, T3 can read at the same time from the shared resource. But if TH4 want to write something in that case, no other read or write will be possible. Now, think of it like a library. Many people can read books at the same time, that's concurrent reading. But if someone is updating the catalog, no one else can read or write. Let me show you a coding example. You will get a better understanding. So in the last video, I have talked about ReentrantLock. Now I'll talk about ReadWriteLock. Here, this is ReadWriteLock. This is an interface. And then we have an implementation class that is Reentrant ReadWriteLock. Okay. Now, if you see this, Reentrant ReadWriteLock, it implements ReadWriteLock. So I have a shared resource class, and in this I have two variables, X and Y. ReadWriteLock I have taken, and then I have two lock, that is ReadLock and WriteLock. So ReadWriteLock has two options, ReadLock and WriteLock. So let me write it as WriteLock. Okay. Now I have two methods. One is read resource, another one is write resource. So here I am, in case of read resource, I am locking ReadLock. Okay. Now, so for read resource, I am locking ReadLock, and then I am printing some output here, adding it to that current X. This is a local variable. I'm adding that X value into this, and here Y value into this. And now I am just calculating the distance from center. Let's say we have a X and Y value. I'm calculating the distance from center. Now I'm waiting for 2 seconds and then releasing the lock. In the write resource, I am taking a write lock and printing it first, the thread name, and then I am adding the delta X and delta Y that is coming via the parameter. So these are parameter, and it is coming here and it is adding it to the X and Y variable, and I'm just printing it out. And then I'm waiting for 2 seconds here, and then unlocking the write lock. So this is simple one. And then in the main class, what I'm doing, I have created few threads. Some has a read resource, some are calling read resource, some are calling write resource. So I've created thread 1, which is a read resource, calling read resource, and write resource, like thread 2, which is calling write resource. Here, thread 3, also read resource. Thread 4 is also write resource. Thread 5 is calling read, and thread 6 is also calling read. Now, what I'm doing, I'm starting thread 1, that is read resource. Then thread 2 and thread 4, these two are calling write resource. And then I'm waiting for 2 seconds. And then I'm calling 3 other threads that are calling read resource. So in this case, what will happen? Let's see. I'm running the program. So here you can see that lock is acquired by thread 1. And now at first, x and y value was 0. So it is showing the distance from center is 0. Now acquiring release the lock by thread 1. Then thread 2 is acquiring the lock. So one by one, right? First is read. First thread 1 came. So read happened. During that time, no write can happen, right? So after it releasing the lock, thread 2 is acquiring the lock and it is calculating the value of x and then releasing it. Then again, thread 4 is taking the lock. So these two are write lock. These two are acquiring write lock. So one by one it is happening. Okay, here also. And then you can see thread 3, thread 6 and thread 5. It is acquiring the lock at the same time. And it's also printing the value and then releasing at the same time. So these are all read lock. So that's why this is happening. So this is the benefit of read-write lock. When we have a use case where multiple threads want to read simultaneously, in that case, we can use read-write lock. So for read-heavy operations, we can use read-write lock. One thing I would like to mention over here is that read-write lock is not ideal for producer-consumer problem. Why? Because in producer-consumer problem, both the producer and consumer are modifying a shared resource. The producer adds the data to the buffer, while consumer removes it. Since both operations mutate the shared resource, there's no true read-only access involved. That's why read-write lock, which is designed for read-heavy scenarios where many threads only need to read without writing, is not suitable for this problem. Instead, it's better to use ReentrantLock with conditions or a BlockingQueue, which handles synchronization internally. So I'll discuss about BlockingQueue in a separate video later. And ReentrantLock I have already discussed in the last video. So I just wanted to mention that read-write lock is not good for producer-consumer problem. That's it for today's video. If you found this helpful, hit the like button and subscribe for more Java tutorials. And don't forget to comment below with your question or suggestions for the next topic. Thanks for watching and keep